Okay, so we are doing the notes for sections 2.4 and 2.5 because there's been a whole bunch of you guys missing. So we have mechanical energy. It means the sum of an object's potential and kinetic energy. So we represent potential energy with EP, and we represent kinetic energy with EK. And we're going to represent mechanical energy with EM. Okay? So energy potential, energy kinetic, and energy mechanical. So when work is done on an object, the object gains energy as a result. So the object is gaining kinetic energy if it increases its speed. So the faster something's going, the more kinetic energy it has. Now, an object is gaining gravitational potential energy if it is getting higher above the reference point. So normally that would be the ground, or sometimes we would use like a table, for example. So EM is going to be equal to mechanical energy and EK is going to be kinetic energy, like we said before. And EP is our potential energy. So as we stated up here, it's the sum, right? Sum. And that's where we get this equation from, right? Because mechanical energy is equal to kinetic energy plus that potential energy that we have here. So, for example, our first example is we have this super fun question here. It's a seagull flying horizontally at 8.00 meters per second. So 8.00 meters per second carries a clam with a mass of 300 grams in its beak. Calculate the total mechanical energy of the clam when the seagull is 30.0 meters above the ground. Okay, so we're going to look at that for a second. What we need to make sure we're aware of is that this is in grams. Now, normally, when we're doing these equations, this needs to be in kilograms. Okay? So, first thing we do, write what you know. So, we have gravity, which we always know that's equal to 9.81 meters per second squared. Our mass is equal to 300 grams, but because we need to convert this grams to kilograms, this is going to be 0.300 kilograms. We have a height of 30.0 meters and a speed or velocity of 8.00 meters per second. So you always need to pay attention to the significant digits, right? So this question here, or this piece of data here has 3 sig digs, 800. This one has 3 as well, 300. And you have 3, 0, 0 again. But they all have 3 sig digs. Pay attention to sig digs. Okay. So now we have our equation, which is up here, right? So EM is equal to EK plus EP. Now, EM is going to be equal to 1/2 mv squared plus mgh. And you may be kind of freaking out right now because, oh my God, where are you getting these from? You can just use the formula for kinetic energy, and you can just use the formula for potential energy as well, right? But both things going on. You can slot them right into this formula because it's EK, it goes down here, EP goes over here. So now we can plug in the info that we have, okay? So 1/2, I'm gonna put the mass, multiply it by 8.00 meters per second. Now what's important, what a lot of people tend to forget, is that this number needs to be squared, right? Woo, so fun. You need to make sure that you are doing that, because otherwise your answer is going to be wrong. So you're going to do plus 0.300 kilograms times gravity. I'm running out of room almost, so we're just going to pretend that it's all on one line. And there we go. So the first thing we do is I like to keep them in their respective chunks. So this is all being multiplied, so we're going to keep it together. This is all being multiplied, so we're going to keep it together. And we're not going to combine everything to the very end. So we have 9.6 joules, because these are all up here. These are all calculated in joules. Okay? So we have 9.6 joules down here for our potential, or for our kinetic energy. And we have 88.29 joules in potential energy. Okay? Now, what's super important to remember is never simplify or round until the very end, because this messes up the precision of your answers, okay? So when we add these two numbers together, we get 97.89 joules of mechanical energy. However, remember, we need to keep in mind 3 sig digs. So our final answer would be EM is equal to 97.9 joules. And but it's 97.9 because this 9 rounds this 8 up to a 9, right? So then once we're done, at the very end, you take whatever. It doesn't have to be a different color. I just like to use a different color. And you put it in a box. That way, whenever someone is marking it, they know that that's your answer. So that's the gist of mechanical energy, okay? So now we're gonna do we have 2 more practice questions, okay? We're gonna do this first one Well, we did this first one in class, and then we have this one as well. So I'm gonna leave these two for you guys to do on your own. And you can always message me and ask if you have questions, okay? So we're gonna leave that for now. Now, we're going to move on to the law of conservation of mechanical energy. So, now this first line is super important because it's your definition. So it's within a closed, isolated system, energy can change forms between two forms we're talking about specifically here, and that is potential and kinetic. But the total amount of mechanical energy, so that's that combination piece, remains constant. Okay? So a closed isolated system means that it's isolated from external forces or outside forces. So no work can be done on it. Energy cannot be added or taken away. So friction dissipates energy is useless heat. So it like uses up energy as useless heat. All this means that potential energy is being converted to kinetic energy, or vice versa. So that essentially means, and this part is what's important, is that EP is equal to EK. All right, so we're gonna do this first example together. It's gonna be so fun. And then the other examples I'm going to have you guys do on your own. So, if EP is equal to EK, you can use 1/2 mv squared is equal to mgh. So a 10 kilogram water balloon was dropped from a height of 12 meters, 12.0 meters. Calculate the speed of the balloon just before it hits the ground. So we have our mass, that's equal to 10.0 kilograms. We have our height, which is equal to 12.0 meters. We don't know our speed because that's what we're trying to find out. And then we also have our gravity, because gravity is always the same, or acceleration due to gravity. So our first step here is to isolate the speed, right? Or our first step, we can start plugging numbers in. So this is the way I would do this question. So first thing I would do is move this so it's mv squared over 2 is equal to mgh, okay? So I'm gonna then multiply each side by 2 so that way we can cancel out the 2's on this side. So now we have mv squared is equal to 2mgh. Now we're going to plug in our numbers. So we have 10.0 kilograms. V squared is equal to 10.0 kilograms. 9.81 meters per second squared with a height of 12.0 meters. Fabulous. So now what I'm going to do is I am going to combine this whole number together. So we have 10.0 kg v squared is equal to 2,354.4 joules. Remember, it's super important to always have your units in there. So next thing you're going to do is you're going to divide by 10.0 kilograms on each side, because whatever you do to one side, you do to the other. So you cross that out. Now we have v squared is equal to 235.4 joules. Now our final step is we need to square root this to get rid of the 2 that's over here. And that leaves us with v, or not joules over here. And I did this in class. Meters per second, because now we're just left with the speed or velocity, right? So here we have 15.344054 meters per second. Now when we put that into scientific notation, that'll be v is equal to 15.3 meters per second. And then we take whatever writing utensil, I don't care, and you put a nice little pretty box around it to make our lives easier. Okay? How fun. So you got these questions to do as well, which we'll be going over in class. Okay? So that is 2.4 in a nutshell. And again, you guys can always ask me more questions in class. I would be more shocked if you didn't have questions after this, because this is a tricky part of the unit. So now we're doing 2.5, mostly because I don't want to make another video because I'll probably forget. That's why we're going to do it all into one. So motion. These are just the definitions. So the most obvious evidence that energy conversion has happened. Because remember, if something has potential energy, it's not moving. But once it has kinetic energy, that means it's begun to move. So change in position is less obvious, but whenever something is raised above the surface of the earth. Surface of the earth. And it's evidence of gravitational potential energy. Okay? Now change in shape. changes shape because of elastic potential energy. So that's the stretching, the pulling. That would be archer pulling back on a bow. Then we have change in temperature. So that would be energy transferred from a hot substance to a cold substance. And this doesn't necessarily have to be like hot and cold. It could be like warm and slightly cool, right? So heat is the transfer of kinetic energy of the particles, because heat is what's causing the particles to move around, right? In one substance to another. So the heat is traveling as kinetic energy through the little particles, and it's moving around, and as it's moving, the heat is moving through as well. Okay? So energy in natural systems, solar energy travels from the sun to the earth in electromagnetic waves. And this is stuff that you guys will have to know for the test. And these would be more knowledge-based questions, right? So it's not going to be a calculation really having to do with this, but it's going to be more thinking about it and applying it to what you already know. So the radiation is either reflected back up or absorbed by Earth. And we're going to talk about that later on in Unit D. So when a sun reaches plants, a chemical reaction takes place in the leaves. This is what we call photosynthesis, right? Photosynthesis is a chemical reaction. A chemical reaction doesn't always need to be some big dramatic explosion, right? It can be as simple as just photosynthesis. So plants and animals that died millions of years ago become buried under sediment, and through pressure and heat, these are transformed into deposits of coal, oil, and gas. So because Alberta was covered in a lot of water, a whole bunch of animals and fossils are like under the surface, and they've been pressurized for millions and millions of years, and now we have oil deposits. Okay, so when these fossil fuels are burned in combustion reactions, they release this energy that was trapped millions of years ago. So the energy is still there. Energy was still there, was just waiting to get released. Okay, and that's why we can use this to do things like power our vehicles, right? So hydroelectric dams, they convert the energy of moving water into electricity. So you have this, and the water is going to go down, 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 down. And the energy of it moving is what is causing it to move. So the water is stored up high, so that way it has high potential energy, right? So if something is high above the surface, it has high potential energy. It then gains kinetic energy as it's moving down, because it's what? Moving, right? And it's traveling downwards. It's letting gravity kind of help it move down. So it reaches the blades, and kinetic energy converts and causes the turbine to turn. So this movement is causing it to turn. The turbines are attached to coils of wire, and this energy is converted into electrical energy. So then we have coal burning power stations. So it's placed in a chamber where it burns at high temperatures, and the chemical energy is converted into heat. Fabulous. So the chemical energy is now heat. The heat causes the water to convert to steam because it's heating it up. Water has a boiling point, right? So it's getting the steam going. And as that steam is going, the particles are moving. So fun. Steam is under pressure and causes turbines to rotate because everything is under pressure all the time. And this energy is converted into kinetic as the turbine rotates, and then when it touches the wire coils, converts back into electrical energy. So then this last little page, there's nothing for you guys to write down. This is just for something for you guys to read through, take your own little notes on. They are important notes-wise, but I would say that you guys should have a fairly straightforward time just reading them, going through. And if you guys have any questions, feel free to message me. Let me know. Very excited. Let me know if you guys have anything else you need. Fabulous.